Dear students, welcome to Organic Chemistry classroom. Today we are going to discuss about indole and its properties. What is indole? Indole contains a benzene ring fused with a pyrrole ring at C2 or C3 position and can be described as benzopyrrole. Indole is a 10 pi electron aromatic system achieved from the delocalization of the lone pair of electrons on the nitrogen atom. Indole's chemical formula is C8H7N. That is, indole is benzopyrrole. It was first prepared by distilling oxindole, a degradation product of indigo, with zinc dust. These are the physical properties of indole. Indole is a weak basic compound. It's a white solid at room temperature. Its boiling point is 253 degrees Celsius. Melting point is 52 degrees Celsius and it is slightly soluble in water, readily soluble in organic solvents like ethanol, ether and benzene. Indole occurs in coal tar and in oils of jasmine and in orange blossoms. Indole ring system is present in many naturally occurring compounds of great chemical and biological interest. It is a parent substance of the natural dyestuff indigo. Indole unit is also present in the essential amino acid tryptophan and in the plant growth hormone indole 3 acetic acid. Chemical properties of indole. Chemically, indole resembles pyrrole and exhibits the usual substitution reactions mainly at position 3 due to greater stabilization of carbonium ion intermediate as compared to that in 2 position. If both 2 and 3 positions are occupied, substitution occurs at 6th position in the benzene. These are the applications of indole. It is anti-tumor, antiviral, antiparasitic, antifungal, then anti-angiogenic, etc. Indole has a bicyclic structure consisting of a six-membered benzene ring fused to the 2 and 3 position of a five-membered pyrrole ring. It is a planar molecule with a conjugated system of 10 pi electrons. 2 from the nitrogen and 8 from the carbon atoms. It thus obeys Huckel's rule for aromaticity, that is total 10 pi electrons. Hence, indole is an aromatic compound. And the resonance structures of these compound is represented here. And the basicity of indole corresponds approximately to that of pyrrole. Although the indole nitrogen atom has a lone pair of electron, indole is not basic like amines and anilines because the lone pair is delocalized and contributes to the aromatic system. Indole is the resonance hybrid of these structures, and thus the structures 1, 7 and 8 are the only ones in which the benzenol 6-pi system is preserved. Its resonant energy is of the order of 47 to 49 kilocalorie per mole. These are the resonance structures of indole. Indole is not a basic compound and tryptophan is a standard amino acid from which biologically active compounds are derived. Another compound is serotonin, which is a neurotransmitter in the central nervous system. These serotonin, tryptophan, and melatonin, these all are derived from the compound indole, that is 2,3-benzopyrrole. Methods of preparation of indole. First one is Fischer-indole synthesis. When pyruvic acid phenyl hydrazone is heated in presence of catalysts like zinc chloride, BF3, etc., indole 2-carboxylic acid is formed, which on decarboxylation gives indole. In other words, Fischer-indole synthesis is the conversion of aryl hydrazones into indoles in presence of an acid catalyst. The second method is Maitland synthesis, and it is the intramolecular cyclization of N-phenylamines using a strong base. Here it is butyl lithium at high temperature. Let us discuss the reactions of indole. First one, reduction reaction. Indole is reduced to 2,3-dihydroxyindole or indolin using zinc or tin and hydrochloric acid. Catalytic reduction using hydrogen over Raney nickel yields octahydroindole. Then electrophilic substitution reactions. Electrophilic substitution of indole takes place in a similar manner as in pyrrole. However, here the electrophilic reagents normally attack at the 3 position rather than in 2 position. Halogenation of indole gives 3 halogen derivatives. Friedel-Crafts acylation gives 3 acetyl indole. Then nitration gives 3 nitro indole. Sulfonation of indole cannot be carried out with concentrated sulfuric acid. However, the reaction with sulfur trioxide in pyridine at 120 degrees Celsius gives indole to sulfonic acid. This is an unusual reaction as normally the 3-sulfonic acid is expected. The reaction with sulfur trioxide in pyridine at 50 degrees Celsius gives indole 3-sulfonic acid. At lower temperature we get indole 3-sulfonic acid. At high temperature we get indole 2-sulfonic acid. These are the electrophilic substitution reactions of indole, and it undergoes Mannich reaction. And what is Mannich reaction? Indole undergoes Mannich reaction with formaldehyde and dimethylamine to give the alkaloid gramine, that is 3-dimethyl amino methyl indole. Then it undergoes Wilsmeyer-Hague formylation reaction. Indole reacts with phosphorus oxychloride in presence of toluene and DMF, dimethyl formamide, to form indole 3-carboxaldehyde. These are the reactions of indole. Thank you all for patient listening.